Hey, long time no talk. All right, so today we're going to talk about what are called geometric series and sequences. And you're going, wait, mister, didn't we just get done talking about this series and sequence stuff? And you're right, we did, but it was arithmetic. Remember, arithmetic was talking about adding, positive or negative numbers to something. So we added a positive number, the series got bigger. We subtracted a number, the series got smaller. Okay, or the sequence got smaller, excuse me. In this one, we're talking about geometric. Well, what is geometric? Well, instead of adding, we're going to be multiplying. And we need to be able to find what's called a common ratio. Before we have what was called the common difference, in a geometric you have what's called a common ratio. How do I find a common ratio? Well, it's actually quite easy. You got to check first. You do R, that's your common ratio, is going to equal your second one divided by your first one, -6. Okay, I go ahead and put that into the calculator. Boop, boop, beep, boop, boop. It tells me it's -1.5. Now, because math people are never happy with just one answer, we always got to make sure that it is truly a geometric sequence, even though they tell us it is. I always like checking and doing the same thing and checking again. Does the same true hold between the third one and the second one? So -13.5 divided by a +9, put it in my calculator, poop, 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 poop. It does come out to be -1.5. So there is a common ratio that's being multiplied each time. So -1/6 times, -6 times a -1.5 gets me 9. 9 times a -1.5 gets me a -13.5. So my common ratio is a -1.5. So then how do I find out the rest of them? Well, I take the -13.5 and multiply it by a -1.5. And again, you type that in your calculator, and what does it give you? It gives you 20.25. And I want to find the next one, so I do the same thing, 20.25 times a -1.5, and that gets me a 30.375. And I do it one more time, 30.375 times a -1.5. Okay. Oops, that should be a negative. And we get a positive 45.5625. And that's it. That's all I have to do. In a lot of ways, this is fairly straightforward and very easy to do. Okay. Let's see what's next. So now I want to do the same thing, a common ratio. Ew, look at all this. Look at all this. This is nastiness. Nastiness. That's one whole term. That's another whole term. So because they're telling me this is a geometric sequence, I'm going to believe them. I'm not going to make you check for the ratio twice on this one. So here we go. Ratio. Second term. -81n plus 243. Divided by 243n minus 729. So what am I going to do for this one? Well, I try and figure this out. So what you want to try and do is you notice, hey, it got smaller from the first one to the second one. So I'm going to try and factor something out of here. And what I see is that, hey, 81 times 3 gets me 243. In fact, if I pull out a -3, right? Okay, so I keep the top the same. And then I factor out a -3 down here. Okay, 243 divided by -3 is a -81. -729 divided by a -3 is a positive 243. And all of a sudden, hey, now I can go ahead and, hey, this up here matches this down here. Gets rid of that. And I'm left with a 1. Because that gets rid of all that over a -3, which is just a -1/3. And that's my common ratio. I'm not going to make you do it again. Just trust me, it works. So -1/3. So then I want to find the other ones. So to find my fourth one, again, that's a sub 4. is 1/3 times the next one, 27n minus 81. Notice that because my ratio is a fraction, okay, my ratio is a fraction, because it's a fraction, okay, my numbers get smaller. When my common ratio is a whole number or something above 1, my numbers get bigger. Okay, so essentially divide each side by 3, and what do I get? I get this being a negative 9 plus n plus 27. Do it again. Okay, so a sub 5, and take the negative 1/3 times my negative 9n plus a 27. And this becomes a positive 3n minus a 9. And finally a negative 1/3. Put that one in there. 3n minus a 9 is equal to a negative n plus a 3. Woo! That was a lot of work. Okay. Now, I'll be honest with you. This is not going to happen many times. You're not going to see a series or sequence. It's going to be a sequence like this, where you're trying to figure out with an n and a number. It's like, this is too much. Okay. Most of the time, it's just going to be straight up numbers. In fact, so much so, I want you to do this next one all by yourself. Okay, so here we are, next one. Okay, so determine the common ratio and find the next 3 terms of this one. So you're going to be asking yourself, am I getting bigger? Am I getting smaller? Should my number be bigger than 1 or should it be less than 1? And that's kind of your checks. So I want you to go ahead and do that. You're going to hit here and pause the video, and you're going to find out for yourself. Pause. You can do this on your own calculator on your phone. Pause me now. And bada bing, there's your answers. Did you get the right ones? Okay. Now mind you, okay, so here my common R value is 3.5. And here are my 3 numbers. The next one's 1029, 3601.5, and 12,605.25. All right. So if those weren't your right answers, you got to come see me or, talk to me about this, because this is pretty straightforward. If you're having problems here, you're going to have lots of problems later. All right, so let's find out what's next. So much like we had a way of finding out and talking about explicit and recursive forms of a arithmetic sequence, there are ways to express explicit and recursive forms of a geometric sequence. So finding the nth term is usually the way, this right here, if you want to, this is your explicit way. Your explicit way is telling you, hey, if I want to find the 15th term, I'm going to plug it into my explicit formula. It's going to tell me what my 15th term is. If I want to find out my 12th term, I plug in 12, and it's going to tell me what my 12th term is. All right, so let's see how this works. So they want me to write an explicit form and recursive formula. So just to help us out here, they said that our explicit formula is a sub n is equal to a sub 1 times the common ratio times n minus 1. So to fill in my formula, I need to know what my first term is. Do I know what my first term is? You betcha. It's a negative 1. And then you find out my common ratio. Again, how do I find my common ratio? I take r. I take my second term, 2, divide it by my first term, negative 1. There's negative 2. And of course, I always like checking myself just to make sure, especially when it's numbers, did I do my math right? Okay, take the third term, divide it by the second term. Oh yeah, hey look, I did. They're the same number. So now I can say that my common ratio is negative 2. And I go in and I just plug in for my explicit form. A sub n is equal to a sub 1, which is negative 1, times r, negative 2, to the n minus 1. And that's my explicit form. Now they want a recursive form. In my recursive form, okay, remember, what am I doing to each term? Each term, look, it's times my r value, times my r value, right? I keep timesing by the common ratio. So what that means is, hey, if I take a sub n And then if I look at the one behind it, right, that's what a sub n minus 1 is. I'm just going to multiply it by the common ratio. Well, what's my common ratio in this case? -2. And with a recursive formula, you always have to declare what your first one is. And so I put a little semicolon there, and I say, well, what is my first one? My first one is -1. So here's my recursive formula. There's my explicit formula. And I'm done. Okay. Let's see about this next one here. Let's see what happens now. So this is the next page of your notes. All right. So on this one, I want you to do it. Okay. Find the common ratio. And I want you to be able to find out, hey, okay, write the explicit and recursive form. Do this on your own. Pause me now. And again, you can do this on the calculator in your phone. So pause. Bam! Hey, did you get those as your answers? If you did, you're right on track. Okay. Again, I should be checking myself. Does this R value of 5.5 make sense? Yes, because each number gets bigger and bigger and bigger. Okay? So my R value better be above 5. Excuse me, above 1. Above 1. Okay? Let's go next. Alright, so now they're asking you to find the 11th term of a geometric sequence. Again, they already tell you it's a geometric sequence, so I'm going to go a little bit faster. If they tell you it's a geometric sequence, then finding the R value is very straightforward. Okay? Although you should be able to tell yourself, hey, is this a sequence of numbers going up or down in quote-unquote value? So I go 122, 115, 110. They're going down. So my expectation is that my R value is going to be less than 1. And it's going to be negative because I keep flip-flopping. Negative, positive, negative, positive. So let's find out. R is equal to, second one, 115.9 divided by the first one, negative 122. I plug that into my calculator and go beep, boop, 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 boop. And I find out that my R value is equal to a negative 0.95. All right. So again, if I want to find my nth term, any term I want to, I'm going to use my explicit formula. My explicit formula tells me it's a sub n is equal to, right, a sub 1 times r to the n minus 1. So what are all those things? So that's where a sub n is going to be equal to my first one, negative 122, times what's my r value? A negative 0.95 raised to the n minus 1 power. There it is. I want the 11th term. So it means a sub 11, negative 122, negative 0.95 to the 11 minus 1 power, which is to the 10th power. But there it is. I just take this right here, plug it into my calculator, go boop, 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 boop. And after plugging it in, I get a nice happy answer of negative 73.04. And again, does it make sense? How can I check my answer? My answer should be a lot lower than where I started from, and it is. It needs to be lower. That's all I have to worry about, right? The absolute value part needs to be lower because my R value is less than 1. So let's talk about this one more time. I come here and I go next. This one says find the 25th term of this geometric sequence. All right, and I go here and I'm going to say, hey, well, again, what's my R value? R value is equal to 291.6 over 324. Put that in my calculator. It tells me that it is 0.9. I already know what a sub 1 is, right? A sub 1 is 324. And now I just plug it into my formula, where a sub n is equal to 324 times 0.9 n minus 1. Again, not difficult, guys. There's your formula. That's your explicit formula. It's ready to go. I want to find the 25th term. 324.9. 25 minus 1, or the 24th power. Okay, when I've plugged it in my calculator, my wonderful, wonderful calculator tells me that's 25.844. It's that simple. Bing. Okay, not difficult. You guys can handle this. So where does it get difficult, mister? Well, when we start doing wonderful word problems. Okay, so here I have a couple that purchased a home for $225,000. It's a nice home. At least here in Texas. Up where in Oregon, it's not a very nice home. Okay, it's like a dirt lot with a shack on it up in Oregon. Okay, at the end of each year, the value of the home appreciates. What does the word appreciate mean? It means it goes up in value. Appreciates, it goes up in value 3%. Write an explicit formula for finding the value of the home after n years. And what is the value of the home after 10 years? So again, in order for this geometric series, that means at the end of every year, I multiply it by 0.03 and add that value on. Well, if you remember from Algebra 2 about interest rates, okay, how do I find R values for this? So when it appreciates, my R value always is going to start at 1. That stands for 100%. And again, am I appreciating means I'm adding, so I'm going to add 3%, but not just 3. What am I going to add? It's 3%. So how do I change percent into a decimal? I'm going to add in there a 0.03, which means it's 1.03 is my R value. My beginning value of my house is my first one. That's a sub 1. So this right here, there's a sub 1. And so I write it out. A sub n is equal to 225,000 times my R value, 1.03, to the n minus 1 power. Okay, that's the first part. What is the value after 10 years? Again, plug that in. 225,000, 1.03 to the 10 minus 1, or the 9th power. And my wonderful calculator would come out and tell me that it is 293,000. I can't read my own numbers here. 573.96. And that's how much it's worth after 10 years. Does it make sense? Did it keep going up? Yes. It's worth more. So I did everything that looks like okay. All right. So then I go to my next one. Again, the key here is the appreciates. How do I determine R value from words? So in this one, we have a boat. Boats and vehicles work in the opposite ways. He purchased it for $12,500. By the end of each year, the value of the boat depreciates 4%. Write an explicit formula for finding the value of the boat after n years. And what is the value of the boat after 12 years? Again, so it depreciates. So again, R value always starts at 1. That's 100%. It means nothing is changing. It depreciates, which means minus. How many percent? 4%, 0.04. So that means my R value is 0.96. So it says here, write an explicit formula. So again, A sub n. What's my first value is how much I purchased it. This right here. There's A sub 1. 12,500 times my n, or R value, 90.96. N minus 1. Again, it wants it after 12 years. A sub 12 is equal to 12,500. 0.96 to the 12 minus 1. Again, happy calculator gets plugged in. Beep, boop, 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 boop. And it tells me it's $7,977.99. So just after 12 years, it's worth about $8,000. Which is actually pretty good, okay, if you've ever tried to sell something that you bought. And that's where we're going to take a break. We're going to call it here, all right? You guys have fun. We'll see you guys tomorrow. Enjoy it. Bye.